Okay, in this last video about rational exponents, we're going to combine all the things that we know about properties of exponents and just implement those with properties of rational exponents. If you need to review the properties of exponents, they showed up back in chapter 5, and that's going to be, there's a summary on the bottom of page 364. I definitely encourage you to go back and take a look at that, okay? Just so you can see. All right. So we're going to use all things that we know about rational or about exponents and use that with rational exponents too. Okay, here we have 5 to the 1/2 times 5 to the 2/3. When I have the same base, what do I do to those exponents? Well, you're right, we add them. So I'm going to add 1/2 plus 2/3. And I have to have a common denominator, which is going to be 6. And so this is going to give me 4/6 and 3/6, which together gives me 7/6. So what I have here is 5 to the 7/6 power. Or if I were to write that, that would be the 6th root of 5 all raised to the 7th power. Okay. Similarly here, we're going to simplify. And I can simplify 14 over 20 because I can take out a 2 out of both of those. That becomes 7 and 10. And when I have the same base but I'm dividing, I subtract the exponents. So I have 1/4 minus my 1/2. 1/4, and I subtract my 1/2. I don't know why I have such problems with 4s. And if I have 1/4 and I subtract 1/2, I end up with a negative 1/4. Okay, so this would be 7x to the negative 1/4 over 10. But remember, we can't have negatives exponents, so we need to move it down to the denominator and say that's x to the positive 1/4 in the denominator. Okay. Similarly, when I raise a power to a power, I multiply, so 2/3 times 2 over 1 gives me 4/3. So this becomes 3 to the 4/3 power, or I could write that as, of course, the cube root of 3 to the 4th power. Either one is fine. If it says to leave the rational exponents, you can leave it there. Or if it says write it as a radical, you can write it as a radical. Most of the time I would probably leave it as the rational. But these are the same things. Okay. And then similarly, last one, when I raise a power to a power, I multiply. So that gives me x. I have negative 2/3 times 3/4 gives me negative 2/4, which is negative 1/2. And then y to the 4/5 times 3/4 gives me 3/5. Okay, when I multiply those fractions. And then, of course, remember we can't have negatives, so the y to the 3/5 stays in the numerator. And the x to the 1/2 goes to the denominator. Okay? All those same properties of exponents that we had used previously. And then, of course, you might want to take your radicals and rewrite them with rational exponents. So, for example, following these steps is really helpful. You're going to rewrite it with those rational exponents, but then if possible, you're going to simplify them. Okay, and then if when it's all simplified you still have rational exponents, then you can rewrite it in radical notation. Okay, so this becomes x to the 20th, y to the 15th to the 1/5 power. Okay, because 5th root means 1/5 power. When I raise a power to a power, I'm going to multiply, so 20 times 1/5 is 4. And 15 times 1/5 gives me 3. So when I simplify this, I get x to the 4th, y to the 3rd. Okay. In this next one, the square root of a is a to the 1/2. And here I have the cube root of a squared, so that's a squared to the 1/3 power. So that gives me a to the 1/2 times a to the 2/3. Well, now I have to add 1/2 plus 2/3 because it's the same base. So again, I think our LCD here is 6. So that becomes 4/6 plus 3/6, which is 7/6. And so what I have is a to the 7/6, which is the 6th root of a, all raised to the 7th power. Okay, one more, and here we go. So this first one, I have, essentially it looks like I've got x squared and y, and I'm raising that to the 3/2 power. And then in my denominator, I have an x to the 15th raised to the 1/4 power. Oh boy. It's not terrible though, we'll fix it. Okay. All right, so when I raise a power to a power, I multiply. So 2 times 3/2 becomes x to the 3rd and y to the 3/2. And in my denominator, I have x to the 15/4. Okay? Now I have same base, so I'm going to subtract those exponents. So I have 3 minus 15/4. Common denominator says this is 12/4 minus 15/4, which gives me a negative 3/4. Okay, so I've got x to the negative 3/4 and a y to the 3/2. So that negative is going to go to the denominator. So I have y to the 3/2 over x to the 3/4. I'm going to go ahead and erase this over here since I need a little bit more space. And then what I need to do is rewrite these as radicals, okay? So this becomes the square root of y to the 3rd over, this is the 4th root of x to the 3rd. Now, interestingly, since they're both to the 3rd, I could see the book writing this as the square root of y over the 4th root of x. All of this raised to the 3rd power. I would take either way, though. I'm okay with it. Once you've gotten this far, I see that you've got all the components, but if you went ahead and rewrote it like this, I would be totally fine with that. Okay, so remember those properties of exponents. We used them with integers back in Chapter 5 in Math 65, and now we're using them with rational exponents in Chapter 9. So that's the end of Section 9.2. Keep up the good work, and we'll see you in the next video.